Hello everyone, I would like to switch gears and start talking about graphs now. So the very first description that we would have on a graph is that the graph is increasing or decreasing. So if you had a person who was on a roller coaster ride, not the greatest drawer of people, but hopefully you get the idea. There's the wheels. As long as the person is going in an upward direction, the function is considered to be increasing. Notice in here, if the person was on this roller coaster ride, the person would be coming downward. That's where we say our function is decreasing. And then over here, the roller coaster ride is going up again, so our function is increasing again. All right, so let me show you this description here. This is considered to be a local maximum or the highest point in its region. We can also say that at this point, our function is not moving up and it's not moving down. So we would describe our function as being constant, C-O-N-S-T-A-N-T. Okay, another point that I wanted to take a look at is this one here. This too is not a point where you can say your function is decreasing through it or increasing. This is a point where your function is constant, and this is also a point where you have a local min. So this is the lowest point in its region. Okay, so again, increasing, decreasing, increasing. Your function is constant here and also here. At this point, your function is at a local maximum, highest point in its region. This one, your function is at a local minimum. All right, so that was the first thing. Here's the next thing I wanted to point out. So say you have this function and we can say that this is a local minimum, a local maximum because it's the highest point in this region. What do I mean? So if I circle that point, then this will be the highest point amongst every points that are in this circle. And this one too would be considered to be a local maximum because it's the highest point within this circle, right? It has the highest y value. But of these two options, this is the highest one, which is why we call it an absolute maximum. Okay, so if it's the king of the hill, out of all of the hills that are out there, then it is an absolute max. Of course, you could do the same thing with an absolute minimum. The lowest point, period, is your absolute minimum, even if you have more than one minimum to speak of. All right, another description that you should be aware of deals with concavity. So what your book has done is it shows that if you're pouring water out, then your function is considered to be concave down. But if you are cupping water, then your function is considered to be concave up. Notice this has nothing to do with increasing and decreasing. It's simply just curvature, right? Are you pouring it out or are you cupping the water? So concave down, the way I like to look at it is it means your function is making a frown, right? So if your function had a disposition, it would have a downward disposition, right? And in terms of concave up, if I put some googly eyes here, you can see that you have uplifted spirits, right? You have a smile, right? So concave down is going to be the frown, concave up is going to be the smile. Okay, so this point right here is where you have a point of transition. So you're not concave down, you're not frowning, and you're not concave up, you're not smiling, but rather you are transitioning from a frown to a smile. So if you look here, it says that this is where you have a point of inflection. Inflection. Okay? So you're either concave down or concave up or at this point of transition, which is your inflection point. All right, so I've given you guys a graph in that first day of your notes, and here it is. I'm not going to be able to zoom in on it as much as I would like. So please make sure that you are looking at it directly from your notes so that you can see those problems of which I'm speaking. So I'm going to do problem number one, or question number one, where it says that f of x is increasing. So as I said, if you were on a roller coaster ride, you would be going upward. It needs to look like this. It's going up through the point. So we could say, oh, we decrease through A. At B, our function is constant, but we increase through C, and it has to be an increase through it. So C would work. All right, what else would work? Decrease through D, increase through F, decrease through G and H, and then over here, something interesting happens and then your function is constant. It's not moving up or down, it's staying the same at J. All right, so I think that takes care of F increasing. Okay, the next question is F has a local maximum. So where is it at the highest point in its region? And from all appearances, there aren't any. But I'll get back to this one because we do have a maximum. Maximum is all of those points such that your Y value is higher than the points around it. Right? So let me zoom in on that so that you can see what I wrote. Your Y value is higher than the points that are around it. So I'll come back to that. Okay. So for number 3, it says, where is your function concave down? So this is 3. All right, so if I look at this, then I want to put my googly eyes at the peaks and the valleys if they're rounded off. So I could put googly eyes there. I could put them over this and here as well. Okay, so I can see that my function is frowning through F and through G. I don't want to pick H because it seems that right at H we go from a frown to a smile. So I can say through F and through G. Those are points where my function seems to be frowning or concave down. Okay, so I'm going to fold this up so that you can see what my next one is. Give me 1 second, please. And I will be doing some folding just so that we can get it all very easily within the frame. Okay, 4 says, where do I have a local minimum? So a local minimum means that it is the lowest point in its region. All right, so unfortunately I've covered up the letters. Don't know how I managed to do that one. Look, B seems to work, right? The lowest point in its region. So let's put B down. E seems to work also. Notice if I were to put a circle here, E would be the lowest point in its region. And I'll come back to this one because there's another point that is a local minimum. Okay, I'll elaborate on that later. All right, number 5 says, where's the slope undefined? So when they say slope, they're asking you where's the slope of your tangent line undefined. So can we draw in the slope? So if we go over to A, there's a tangent line there. At B, your tangent looks like that. At C, your tangent line looks like that. At D, this is a tricky one because you have to decide, does your tangent line go this way or does it go that way? So anytime we're conflicted like that, then we can say that our slope of our tangents is undefined. So then we have E as 1 point. Notice F, we can draw on a tangent line. At G, we can draw on a tangent line. At H also. Here's another point of conflict. So anytime you have something that looks like this, a V formation, you can say that your slope is undefined. So I would be a point where you would have an undefined slope. Now a lot of people would choose J, but J's not a problem because you can say that your slope is 0 there. Okay? Now problem number 6 says, let me write the numbers here so you can keep track. Okay, problem number 6 says, where is f of x decreasing? So it has to be going down. Okay, so look, A works. If we're on a roller coaster ride, we'd be coming down through A. What else works? D works. Our roller coaster ride would be coming down through D. Also through G and through H. Through G and through H. Okay, now number 7 says, where does F have a point of inflection? This means that you went from a frown to a smile. And coincidentally, it's the same thing as if you go from a smile to a frown. So as long as you're going from concave up to concave down or concave down to concave up, you have a point of inflection. And it appears that that's the point we're talking about. You can see it, frowning to smiling. So if your function is bipolar, it was happy and then it's sad, or vice versa, then that is the point that you're interested in. There's H. Okay, so 8 says, where's your function? Let me fold this up, make it a little bit closer. All right, so this one's number 8. 8 says, where's your function concave up? So where is it smiling? So your function is concave up at A and B and C. Those are the main points.